start. Okay. Good afternoon, everyone. Welcome to this AI Governance in Action. To know more about how do we create a secure, responsible, and trustworthy AI systems in our companies. So to take it forward, a brief about CISA. CISA is as such a forensic-driven cybersecurity solution company, and we've been trusted by organizations across the globe for our secure business and robust preventive, detective, and corrective security services and solutions. So we have as such done around 1,000 active engagements every year, and our global customers base is more than 2,000 as of now. Okay. So brief about our presence. If you see here, we have our presence in USA, Canada, UK. In the Middle East, we are in Saudi Arabia and Qatar, Bahrain, UAE. So we have a presence at multiple places. And just to give you an introduction about the speakers today, so we have here Renju Verghese, who is a seasoned cybersecurity expert with around 18 years of experience. Okay, and he is as now the Vice President of Forensic and Research at CISA. So he's been as such in the cybersecurity arena for a long time. And he has also led the leadership to the launch of AI Prism, which is a privacy risk identification security management in AI systems. So to know more about him, so he has multiple certifications with his baggage. So he has certifications in CISSP, CISA, Certified Forensic Analyst, Core Payment Forensic Investigator, Payment Card Industry Qualification, PCI QSA. So a lot of certifications is what he carries in his baggage. And some of his expertise are AI and machine learning security, digital forensics, managed detection and response, payment card industry, and many more. I would like to introduce our second speaker today, Dr. Anjan, who is also a seasoned cybersecurity expert with over 18 years of experience. He holds a PhD in computer science and engineering, and he has authored over 75 publications in reputed international journals and conferences. So more about Dr. Anjan. In addition to this, he also is a research and industry leadership. He has served as an adjunct professor with BITS Pilani for the Wipro BITS WILP program. And he also holds numerous certifications along with his qualification, which is a PhD in CSE, MTech in CSE, and BE in CSE. And apart from this, he also has a lot of awards and achievements. He's got a Best Research Award for Project in Kleptography, Emerging Research Award, published 2 books with over 75 research paper, including 19 Scopus indexed, 4 patents filed, including 1 in artificial intelligence, and best PhD thesis, and many more. So with this, probably I would not take much time and hand it over to Dr. Anjan to take it over from here. Over to you, Dr. Anjan.
Thank you, Kitchen. And thank you for the introduction of the speakers. And let's deep dive in the today's session of what we are looking at. So with the context of the AI governance and AI governance, it is very essential to understand the point of why AI governance is taking a lot of limelight today. It's because of the faster and lightning speed of adoption of Gen AI and AI coming into picture today. And that also brings us to the point that to the basic and a very fundamental question of why AI, right? What is the importance of AI? And the AI is bringing up with its own fundamental activities of what is basically AI and why is it bringing up with several different threat vectors with respect to AI. So the context and the objective of this particular webinar is to set in the shape of the futuristic secure AI application, which can be used for enterprise applications as such. So let us try understanding the construct of an AI. Now let's say that there is an AI which is trying to predict the rain and and trying to plan the predict the traffic pattern as well. So as an AI, it doesn't have an intelligence. Someone has to provide an intelligence to the AI system, right? So the AI system basically learns from observing from its environment. So it basically observes the pattern and how people react when there are circumstantial parameters which basically change around it. And that is where we see a lot of things changing with respect to AI. So observing patterns and looking at how patterns basically changes with respect to AI. So what AI would look at is it looks at various different parameters of observing cloud, rain and an umbrella and associated parameter with that particular scenario. And it has to draw a conclusion of when a rain happens, why is that there is a traffic flow, right? So that is where it sees multiple real factors and parameters which are surrounding that particular scenario, and tries to learn and combine multiple different outcomes that basically affect that particular situation. So this is basically the training of that particular intelligence, right? So it learns by watching thousands and thousands of examples which are basically out there, and what basically happened with respect to each of these circumstances and scenarios of what we see. And with respect to each of these scenarios and the combination of these scenarios, the model basically tries to learn from that particular environment. And that is where it basically draws a conclusion that there is an 85% of a chance of a traffic jam, uh, basically because there is a likely heavy rain which is basically happening, right? So there is one predicate and one outcome which basically happens with respect to this. And this is where AI basically predicts the based on observing the circumstantial parameters which are surrounding it. So to go ahead of it, it also tries learning that same multiple number of times. So learning makes it perfect. Just like we say, writing make things perfect. Learning in AI world makes it better. So AI improves with its experience by more accuracy every day by learning and observing about it and trying to add on some kind of an improvement with respect to what it has basically learned. So with this, it also tries adapting to the environment and trying to make changes which is basically required for it. So the construct of AI, what we see today is a narrow AI, which is a factual representation and generation of facts. And what we are trying to move towards is a general AI, which is basically ahead of the factual generation. And it's a knowledge creation and knowledge representation, right? Going further ahead is the concept of super AI, where we are trying to talk about the compute is no longer there, and it's not just the compute, it's the conscious, which is equivalent to that of a human. So this is where adapting to the environment starts, and adapting becomes a very important point of it. So in summary, when we look at machine learning or AI, the common criteria what we see about it is identifying and creating a appropriate data set which is required to train the machine, perform a certain computations which is basically required, which recognizes the patterns, rules, and creates a relationship among it, like what we saw in the previous example, and then take correct output decisions what is required with respect to it. So these are something which are routine machine learning activities as what we see with respect to it. So we have several different algorithms which have been there from several decades. It's not a new version of it, but it has been used in one or the other cases. But today with the transformer architecture, we see something more coming up with it. we had a categorization of supervised learning, unsupervised learning, and reinforcement learning. And we see certain candidate algorithms which are very popular under each of these categories, and their typical use case of where it is going to be used with the guided process of the data set, what is basically provided with respect to it. So this is the summarized view of ML algorithms as what we see, and there are dozens and dozens of algorithms which are already available out there, and each one of them meant for a different purpose altogether. So you can experiment that also in the OpenML and other significant platforms, which basically gives you a hands-on on how it looks like. Likewise, when we look at further in the divisions of the artificial intelligence and the machine learning part of it, something which came as a add-on to this machine learning and trying to combine multiple machine learning in a different way is the deep neural networks. Just trying to mimic the neural network, what was there in terms of the human brain and how this human brain interaction can mimic. So the deep neural network came into existence with several different operations at short and combining multiple different capabilities in the neuron with respect to it and trying to do something like this. For example, if a machine learning has to do, there is a feature extraction and a classification that needs to be done for an object recognition. Now, with the deep neural network, I have certain layers trained upon for feature extraction and certain other layers trained upon for classification with respect to it. So at the most, at the outcome, what is being looked at is with the supply of an input, I'm just trying to understand that whether this particular image is something to do with the object identification as a car or not a car, right? So the deep learning combines multiple different features with respect to it. When you look at the neural network, it simply signifies and mimics the same ability of a human brain, where there are multiple neurons which are basically connected and they are exchanging multiple different information to different part of the human body. So in the neural network context as well, we see that there is an input layer, there is a hidden layer, and then there is an output layer. The input layer are the set of nodes which basically receive the input, and each neuron basically corresponds to that particular input which is basically provided. Then the hidden layer is where there is a heavy computational lifting, which basically happens where there are multiple hidden layers which keep processing this particular input. And then there is a final output layer, which basically is the desired output of it. And the entire neural network is basically uh, in a very feed forward and a feed backward or a reverse network, where if there is a requirement to calibrate that particular output and make it much better in terms of accuracy, we use something called as propagation to update it. So with the use of the neural network, the larger research came into existence, and with the change, where we saw a remarkable change in the natural languages or the language system, which we see as the transformer architecture, which is a foundation for Gen AI as what we see today, right? Way back in 2017, where it came, right? So all the LLMs and other technologies, what we talk with respect to the LLMs, are primarily based on the architecture of transformer architecture, which composes of two different stages. One, an encoder stage, the other, a decoder stage. The encoder stage is basically to understand the input. The decoder stage is basically to generate the output with respect to it. So when we look at the encoder stage is composed of multiple different sub phases, starting from tokenization, where let's say that I give a word as hello world. So the hello world is individual tokens which needs to be broken into digestible piece by machine, right? So machine does not understand a human language. It is made to be understand about the human language. So that is a process where we start with this encoder. Then the tokens which are basically created are into the embeddings, where they are given a numerical value for it, because mission basically understands number, not the language, as I said. And then the mission is also made to understand that there is a positional encoding. There is a way in which the text basically flows. There is an order of the words which needs to be followed with respect to it. And that is a word order which is going to be used with respect to this. And then what is being looked at is the self-attention layer, where the self-attention layer basically talks about how each word helps understand the other word better. So it's a multi-head attention system is what we look at in the transformer architecture. And then it goes ahead with the calculator of the feed-forward neural network layers to look at the attentions and try finding out the understanding with respect to this nuances what is being created. Now, when you look at the decoder stage of this particular transformer architecture, it is completely on self-attention of the outputs. Cross attention is in fact, and the encoder decoder attentions are basically looked at. And then there is a feed forward network which will be talking about the processing of the decisions before it is out, and a final prediction of the output, which is an outcome of this particular transformer architecture. Although this is a very complex architecture, just trying to bring in a glimpse of what it basically looks like. Moving ahead, there are multiple different examples which are there with the encoder and the decoder stages of this particular transformer architectures, where each stage is very clear in terms of understanding the tokens, understanding the vector embeddings which are there with respect to these tokens, the positional encoding of where which token has to come at what kind of a position is looked at. And it's a sequential process looking at 1 2 3, and then after that you see a self attention of where the attention should basically come on. Should it be on cat, should it be on sat, right? Should there be another mat where there is another token coming into picture? Where is the attention basically coming into picture with respect to it? And then it goes into the feed forward layer with respect to understanding and refining these particular words with respect to their context. So that is the point where real world examples of any LLMs or Gen AI architectures, what we talk about today, are looking into the understanding part of it with the encoder part, and then decoding the required output that needs to be generated out of this particular set. So we also see that there are traditional learning methods which have been there for more than 2 decades plus now, and we can see how the traditional learning methods, where if I take a synonym of it or analogous to a real world um, a problem, they basically look like a manual car driving process, as what we have as a gear stick, clutch, brake, and accelerator, where there is a need for a human to have a supervision at every stage and create that particular process to drive this entire system. So which is a typical traditional machine learning way of doing it. So what ML systems did as and when they advanced was trying to automate this particular feature and trying to make it less manual and more automatic, with the automatic drives coming into picture. But they still need a driver to drive this particular um, a car. Uh, and then we had the era of generative AI, where ADOS feature started coming into picture with adaptive cruise control, trying to learn the environment and trying to adapt with respect to the environment, trying to handle dynamically of what happens with it, and trying to maintain a self-drive on the lane and other features which started coming in with respect to it. So that is what generative AI is trying to do. And moving ahead in today's concept, what we see is a agentic AI with a completely autonomous vehicle, where it can perceive, plan, decide, and act independently to achieve goals. And we see this as to be a very typical example of a Waymo driverless cab, which is available in many parts of the world, specifically in US. And you see that this is agentic AI, which basically works on multiple different technologies using LiDAR, as well as the camera, which is used for the perceptron and the prediction part of it. And then there is a decision making capability which is there with respect to it. and where it acts as a human brain. So there is nobody sitting on the driver's seat here, but the car taking autonomous decision to plan and go ahead with the prediction of routes, and as well as go ahead with what is required to do the actuators, which is to throttle and brake whenever it is required based on the circumstantial factors which is around that, and then going ahead with the actual thing that needs to be put on the actual road. So this is the way forward of what we are looking at as a super AI kind of a construct, and how things are going to be with respect to the super AI. So moving further, I would like to hand over the session to my colleague here, Ranju, to take.
Sure. Um, thank, thanks, Anjan. Thanks, Anjan, for covering the foundation of AI. Now, let's look at how the clients or enterprises have gone with using the AI. So when we talk about AI, we're mainly talk about LLMs and MLs, and how it's been used in a real life applications across various environments. So to start with, we have the our traditional application deployments, right? Where we just have an user who's going to access a application interface, which is going to have a application logic running behind, and just going to connect to the database for getting the data sets. Then came the machine learnings, right? So if you remember the Amazon Alexa days, right, which basically is converting your voice into from a natural language processing to the digital context, and then processing the same. So which conversion of your voice to a NLP is basically nothing but an ML algorithms part. So we had uh, quite long back itself, we had various ML algorithms running, which was being mainly triggered within the application workflow. So you don't have any changes or you don't have any calls to be made from the user specifically. It mainly gets triggered within the application workflows. So, and whether it is an image, voice, or any kind of sensory data, or basic data itself, it is to get processed by these ML algorithms. Some of the examples we had in the ML is definitely from a payment industry. We had these MLs running for fraud analysis, especially for identifying if there is any anomalies with regards to transactions. Uh, we had the natural language processing for detecting from voice to text and from text to voice as well, and also extracting the content from images and those constructs. Moving forward, right, when GPT got introduced. So in the initial days of 2023, after GPT got introduced in 2022, we mainly have seen is that the clients and customers having directly integrating these LLM as a direct chat interface within the applications. So in going forward, when I talk about LLM in the slides, please note that these LLMs can be deployed in two different manners, right? One, directly calling to the APIs of LLM providers like OpenAI, Gemini, or Microsoft Copilot. The second option is hosting the LLM and say getting the LLM from various sources like Hugging Face and hosting within your cloud environment or your data center. So in the initial days of after GPT got introduced, we have seen is the clients having a direct interface to these LLMs, and was being mostly being provided as a chat interface. So most of the clients or most of the organizations called it as a co-pilot, not Microsoft Copilot. Before that, they were just using terms Copilot, and we had seen a few POCs at that. Then came were the second type of implementation that we have seen in the industry, were they were using it as a um, component together. So we had ML algorithms, and also we had LLMs, which has been acting in part. So we basically saw it in the BPO and the KPO industry, where they used to get the images or the voice files, and convert using a ML algorithm into a text format, and then send that particular text format to an LLM, basically for a summarization function. So we had the call summarization done by BPOs, and a lot of those activities we have seen with regards to the second type of the deployment part. So it was converting using ML to convert from image and voice, and then using LLM for the summarization part aspect. The third component that we saw was where the LLM was being integrated within the application logic itself. So, say for example, it was mainly done for the document analysis or image analysis part, and then asking the LLMs for any suggestions or to take any decisions aspect. The initial use cases that we have seen here was especially in the HRMS portal, for basically reviewing the various resumes. So we had seen the application just collecting all the resumes, reviewing through the LLM to see whether the resumes fit to the job description of the particular requirement, and then taking a decision whether it is yes or no, and then moving forward. So we are also have used similar logic for our internal application called Sys Assistant. So where we are basically trying to use LLM for reviewing the evidence so that it can be much faster and the clients can get the results much earlier part. So, and in this aspect, again, it was mainly triggered within the application workflow itself, because and whenever there is a requirement, it used to interact with the LLM and get that particular decisions done. Then, so till now, we basically have seen where whatever is the input which the user has given, with the application just process it within the LLMs and then gets the output. But if the organization want more accurate answers, which is more relevant to the organizations, we've seen the deployment of RAG coming into picture. RAG is nothing but retrieval augmented and generation system, right? So in the case, the organizations used to upload their data set into the RAG database. So it's more of a vector database. And so what happens is when a user queries, the query is sent to the RAG or the vector database for retrieving the specific context of that particular query, right? So if you want to take an example, one of the deployments that we have seen is where, uh, again, within the HRMS applications, they have, say, uploaded the organization policies, the organization SOPs and everything. So if a user queries that, okay, please give the holiday list for the year, then basically that query goes to the vector database, and from vector database, it retrieves those specific holiday list, and then the application sent both the query and the retrieved context from the RAG to the LLM for a response back. So that was the other type of deployments that we have seen. Uh, in case if you're using Microsoft Teams, and Microsoft have an option of creating this similar RAG flow within the Teams chat, where you can upload your SOPs and other internal documents within the Microsoft Teams, and then when the user queries it, it basically retrieves those specific content and answers it back. So this was the the deployments that we had seen from the RAG deployment part. So that when the LLM gives you an answer, it is more relevant to that particular organization. The next one, or right now what we're seeing is with the introduction of NCP, we are saying that we don't need a actual RAG to be in place, right? So NCP is a multi-context protocol which helps applications to uh, link multiple LLMs together and then able to provide those specific service. So here, as a action point for the workflow one, when a user enters a particular prompt, or whether it is being triggered within an application workflow, the application uh, have again a workflow which basically say sends this what is a requirement, right? So let's take an example of again the HRMS application, and within the HRMS application, I'm just mentioning that give me the list of holidays. So the application logic just sends that query to, let's say, LLM2 with a prompt stating that give me what is the specific parameters to search in the database to fetch these details, like the holiday list and everything. So LM2 basically gives those set of parameters. Then using the MCP, they basically send those query to the database, retrieve that particular content, and then the query and those particular content is again sent to an LLM for giving the answers back on the response back here. So in this manner, what has been actually seen is that the entire uh, use case, the POCs of going live becomes much more easier, and the when the applications goes live with these AI systems in place, they are able to give a lot of the specific context specific to the client and specific to the customer, because every query we are retrieving it directly from the database and then sending it to LLM for answering it back, right? So we have seen quite a lot of these implementations out, and this is what we believe is that is going to come part till there is any new advance, because as you know, every week there is a change or as an evolution of those AI systems. So till now, this is what we have seen with the MCP become introduced. Now to give you a few use case, right? Because one of the deployments is that how would you bring agentic AI into this entire context, right? So these are a specific use case that we have tried it in CISA to introduce AI into our cybersecurity monitoring part. So in our initial trial, we have a solution called Proact, which we provide monitoring service. So we're just giving a use case. The same logic can be deployed for your applications as well. So in this particular use case, we definitely get the logs and the data and everything. Now we had our ML algorithms, like anomaly detections and everything, which basically tries to identify specific alerts. We had rule-based logic to identify those alerts part. So as you know, in the SOC, definitely there was a requirement to ensure that the alerts are true positive, and there's very less number of false positive alerts. And we're seeing that whether the entire process can be automated. So what we did was we brought in an LLM and we deployed a chain of thought prompting method. So basically here, the prompt one basically asked to analyze the alert and confirm whether the alert is false positive. And within that particular same prompt as a chain, we say that whether the LLM requires any additional logs required to confirm if it is a false positive uh, alert part of it. And if the LLM states that, yes, I need additional logs, then the prompt tree is basically asking the LLM to give me those specific Elasticsearch query so that we can fetch those additional logs. Why Elasticsearch query? Because we use Elasticsearch in the backend for the logs. And then once we get a query, we query it into Elasticsearch, fetch those relevant logs, and again send it to LLM back state asking that, hey, now there are additional logs, confirm whether it's a false positive or a true positive. So here, the basic logic that which we had used was basically to identify whether the alert was a false positive alert or a true positive alert aspect. But definitely we ran into a lot of problems when we went live. So not a problem, it's a limitations we can say. One was the it was limited on based on the chain of thought prompts that we created, right? And there were a lot of prompt engineering techniques which we had to use to enhance the quality of the analysis. And it was not self-learning and it was not dynamic enough. And this was most of the problems which most of the clients used to face, or most of the organizations used to face when they went with the initial use case of using LLM. And that's where the agentic AI came into the picture. So we right now have an agentic SOC deployed. Now in this agentic SOC, again, we have the data layer, the logs coming in, and we have the agent one, which basically runs all our ML algorithms, UEBAs and correlation rules and everything, and for getting the alerts out. So again, in agentic SOC, we still have the same goals mentioned to confirm whether the alert is true positive or false positive, and to see what actions to be taken to mitigate that particular incident. To facilitate that, it is required that we need to have a orchestration agent, right? So the orchestration agent, the requirement of an orchestration agent is to ensure that it is basically able to orchestrate or route the workflow in the proper manner. So we had an orchestration agent. So the first step of the orchestration agent was to get the alerts generated by agent one and send it to an agent two, right? So for agent two, we basically used Falcon LLM, so which is one of the best LLM for basically just analyzing the events and the incidents part. So it basically what we put across is to see whether the alert, it's basically does a triaging of the alert and basically analyze that particular alert and analyze that particular events and just gives that particular output, what it has analyzed. Now, we got that agent to output into our third agent, which is basically what we call as an investigator agent, which had an LLM and a RAG in place, right? So in the agent tree, we had the RAG, which is a vector database, which contained all the historical ticket details of that client, whether the vulnerabilities of that particular client architecture, and whether the latest results of the client's VAPT results and everything was stored here into this particular RAG, right? So after the analysis of the from agent 2 to agent 3, I mean agent 3 basically, because it had a lot of these context behind the same, right? On what all kind of events has happened, what does the client's architecture looks like and everything. It's able to analyze the incidents even better and give you a much more crisper response to your to that particular alert. Now, apart from that, if they want, if the agent investigator agent want more details, like the logs and everything. Then we had an integration agent, which is basically a set of existing tools of the clients and can integrate and fetch the data. Like, for example, EDRs of the client and fetch data directly from the EDRs or from the firewalls, directly fetch the data and give it back to the investigator agent for the analyzing the alert part. In case if the agent wants or the investigator agent wants more details, then it went to the threat intel agent for any additional queries uh, or additional intel that it needs to pass on. So these informations again gets fed into the investigator agent, which analyze the incidents and then sense it. So we had the QA agent, which basically analyze this particular set of incidents and share the feedback back to the investigator agent, right? So here in the QA agent, it basically is analyzing it, and if there is any false positive or any thing comes in, the feedback is given back and stored into RAG, so that there is a learning loop coming back, and investigator agent is improves its analysis even better. And definitely we had the agent 7, it's a responder agent, where what is based on the decision which has been taken, it goes back and we have a decision tree with an LLM, which basically takes it decision and take it forward. So we're just given our example of how we have gone ahead for an agentic AI implementation. So similarly, you can definitely use your own uh, architecture and use and go for agentic AI deployment. The points to note out here is that when you talk about agentic AI, it's not just one LLM being used, it's multiple LLM used and also with multiple uh, tools which can actually improve the entire workflow architecture part. So once we deploy this agentic AI, the questions comes with responsible aspect. And for that, Anjan.
Yeah. So the context of looking at ML and looking at the artificial intelligence and a practical application of where LLM is basically being used, the very important today on the regulatory and the governance framework is how do you make this AI as a responsible AI part of it? And that is the place where responsible AI matters a lot, because everybody has pressing concerns on governance as well as regulatory aspects with respect to it. And AI as such, you know that it is being trained on both legitimate as well as the jettison data, and it's very important that throughout the life cycle of AI, that the AI remains responsible itself. So to make AI responsible, the parameters which needs to be looked at is that the AI risk components should basically look at fair and not biased. And there are several different examples out there talking about a recruitment system going wrong with the bias and always trying to shortlist a particular type of gender or a particular race and other aspect of it. So the fairness is something which is a very paramount important factor for a responsible AI component. Likewise, we have AI decision making to be auditable when it can only be transparent in terms of its decision making and trying to make the process understandable and interpretable in terms of the business explanation of what we do, and also looking at why did it basically take this particular decision. So there is a transparency with respect to the decision making ability of AI. And of course, the third most important parameter what we look out is security of the model itself. How secured is by my model, and how is it that it has a large integrity question which is hanging on it, and whether it is crucial to be integrating that particular model into the system, because there are chances of sensitive data and other things being used for it. And securing the AI system to protect against any kind of sensitive data and maintaining its operational integrity is utmost important for a responsible AI to be looked at. And also, it's important to look at how a responsible AI can be a safety as such, because when we look at an example of a Waymo driverless car, safety is a parameter which comes in as a very paramount importance. It's a trust of the user to go into such kind of a system and be safe with respect to such kind of environment. And safe environments where AI is being used can also build trustworthiness of that particular environment. And obviously, the data privacy is a paramount important factor of AI systems. Trying to protect user data, PIA data, PHI data, if it is a healthcare related version, and trying to be compliant with multiple regulations like GDPR and several other regulations which are there out there throughout the globe. Ensuring that there are no unauthorized access to sensitive information and confidential information, and there is an absolute control of that particular information itself. And sixth important challenge today, which most of the AI systems are facing here, is the toxicity of it. How do I remove harmful, biased, and offensive outputs, which basically comes in with large language models? And every time when there is, information which is basically put in, and there is a user trust which basically comes in with respect to it, and it's very important to promote the ethical use of AI with such kind of toxic cases. And a responsible AI should be an AI without toxicity. That is a very important parameter. And obviously, the model accuracy also matters to a larger extent. So the response or the inference what is received from the particular model should be accurate enough to what is the prompt that was basically given to it. So the prediction, the classification, and the decision-making process which the model undergoes individually within it should be of high accuracy and should be critical enough to take trustworthy actions of that particular system to which it has been integrated with. And that is where responsible AI components matters to a larger extent. Over to you, Ranju.
Sure. So the question is that how do you prepare, right? So once the organization starts implementing these AI systems into picture, what are the steps that you need to take to ensure that your applications is a secure, responsible, and trustworthy AI? So the first step to be taken is to ensure that the AI itself is secure. And for that, the first one is identify whether your AI systems has any vulnerabilities, right? So vulnerabilities like your prompt injection vulnerability, toxicity, or any jailbreaking or an evasion attack part. So how do you go about doing that? The activities to be carried out there is basically an LLM red teaming, which basically tries to identify if the LLM itself has these vulnerabilities in place. The second one is a Gen AI application red teaming, which basically is targeting on how the LLM has been integrated into your applications, your application workflow, and through your applications, can it be broken? Can the application logic can be broken through this LLM? So that is the Gen AI application red teaming. Third one is definitely your testing of your entire AI system infra aspect. Now, in the industry, there is something called as continuous LLM red teaming, which basically is ensuring that there is continuous testing of the LLM, because every day there is new ways of test cases is being introduced, which can break the logic of your LLM or can break the guardrails of your LLMs. So it's continuous red teaming to identify if your LLM is vulnerable. Now, once you do the vulnerability assessment, then is trying to identify the risk in the company data which has been used by the AI systems, right? So the risk like whether the data set which has been used by the AI systems to take a decision, can it lead to a biased decision part of it, right? Whether the data which has been you've been provided to this LLM has any confidential data within that data set, which can lead to a data leakage or a confidential data leakage aspect. What are the activities to be carried out here? Is definitely the data scanning. A data scanning to identify if your data set has any confidential data, and also a data scanning to identify if your data set has any bias data set in the place. So because if the data is biased, then the output will be in a biased manner. Once you identify those set of risk and vulnerabilities, what's the next step? The next step is trying to mitigate those particular vulnerabilities. How do you go about mitigating it? The one way is to do is secure fine-tuning of the LLM. right? So we have the LLM. So as the LLM has been trained, we can again retrain the LLM models called secure fine-tuning to ensure that the LLM itself will not be toxic in nature and it won't share you those malicious inputs out. And as a layer defense, like you have your firewalls, there is something called as the LLM firewalls, which basically analyze your request and response and ensure that the request and response is falls within these uh, requirements and doesn't has any malicious content in place. Is it different from your WAF, that is web application firewall? Because WAF looks at the request at the HTTP and HTTPS layer part of it, while in this LLM firewall, it basically looks at the context and see whether uh, you're putting any malicious context or the user is asking the LLM to break their logic and give it back. We can have LLM guardrails, which ensures that LLM works within that particular goal that it has been defined. And we have the secure ML ops to ensure that, like your DevOps, we have the secure ML ops function. And for regarding data, definitely the secure data handling comes into picture. Now, once you brought in security to your AI systems, right, by identifying the vulnerabilities, fixing the vulnerabilities, the next component to ensure that your AI is responsible, right? So how do you make sure that the AI is responsible? So for that is definitely defining the AI system's goals and guardrails, right? Uh, Goals basically saying that, okay, what is the specific functionality of that particular AI system, right? What should that LM should only be doing? And guardrails is basically limiting that particular functionality to the goals of that system, so that there is no lot of enormously actions which has been taken. Say, for example, coming back to our use case of our agentic SOC, some of the guardrails that we have put in place is that the LLMs cannot go ahead and take a response action to our SOAR immediately. There has to be a user function in place. Because if the LLM says that, okay, now I have to go and change all the passwords and it changes all the passwords of your database and everything, then your application might get stopped, right? So it is important to ensure that there is a set of guardrails which defines what goals can does LLMs can take. So how to go about doing that is basically once you deploy the goals, you also need to monitor those AI systems, right? Because if you're not monitoring those AI systems, the request and response and the actions it takes, there are a lot of chances it can happen, right? There can be an adversarial attack which doesn't get stopped by your LM firewalls and the guardrails. There is a chance of a confidential data being uh, inputted or being taken out. And more importantly, there is a chance that the model gets drifted. So in the entire deployments, there's something called as a model drift, where the model moves from its intended goals part of it. So if you have monitoring in place, what we call as the observability or AI observability, which ensures that the model drift, data drift, and these things gets taken care. And once you have secured and once you have the responsible in place, the third one is building trustworthy. Why trustworthy, right? Even if you have all the controls in place, it's important to demonstrate that you have these necessary controls and systems put in place to safeguard your AI. And to do that, definitely the one currently in the industry is ISO 42001, which similar to the ISMS is AI management system, right? So it's about conducting the AI risk assessment part of it, and more importantly, doing a AI inventory scan. So as an information security professionals, when we go and talk to the developers saying that, or go and talk to the vendors and say that, hey, what all MLs and LLMs have you integrated? They may just only give you one example, right? They may not give you all the LLMs which has been integrated. So it's important to do an AI inventory scan to identify what all ML components, what all LLMs has been incorporated into your application so that you have a better clarity uh, part of it. And ensuring that any vendor or any third party support team who is actually deploying in an application environment, managing it, a part of it, or if you're using any SaaS applications, which is uh, using AI systems in the backend, you bring in, ensure that those third parties follows the secure, responsible, and trustworthy AI, because in this entire journey, you need to ensure that your entire ecosystem is secured and follows the responsible AI parameters. It's just not about you. It's also about your third parties and your uh, support team, which or your vendors, which you need to cover apart. So with that, we're just only giving you a very small glimpse of what it is part. So for more details for regarding what you can learn more, we have our own certification program called CSPAI. Anjan?
So, Certified Security Professionals in Artificial Intelligence is a world's first ANAB accredited program in cybersecurity for AI, and it's also a certain endorsed program here in India, which basically talks about the entire landscape of AI and how the landscape of AI is dynamically moving towards the faster growth and adoption of AI into the industry today. And it also dwells with the architecture of the newer generative AI, inclusion of transformers architectures, and what are the various ways in which the training have been looked at, and what are the different levels of fine tuning which is basically required for the LLM models, especially for those with the open source LLM models. And of course, the ultimate aim of using a LLM is to integrate within an application, and what are the different architectural styles of integrating that LLM within architecture, LLM applications. And then further to it is the place where we look at a lot of analyst trends like the Gartner and Forrester coming up with what are the futuristic trends of Gen AI, inclusive of the hype curve of Gen AI, and the what is the latest technologies which are happening with respect to it. LLM vulnerability and exploits, where we look at the OSWAP top 10 LLM vulnerability, Mitri Atlas ML framework, and Google Secure AI framework as a three important vulnerability framework that is basically being covered in it. And of course, the AI risk assessment and the governance framework at a larger picture with our own process, which can basically be used for EU Act or ISO 42001 or any other different governance model what we basically look at. So with this, I am just leaving you with the key highlights of this particular program, which is the CSPI. There is a QR code also available on the slide what is being showed up, which can give you a further insights of what um, the program basically talks about in depth. So those of you who are interested can go through this. And also our own set of offering which navigates through the secure AI, responsible AI, and the trustworthy AI with respect to it, where there is a requirement of understanding the vulnerabilities as looked at in the secure AI, trying to fix those vulnerabilities at the second level, and trying to make them responsible with respect to different things, and then the trustworthy factor of it. And this is our comprehensive solution stack of CISA, of how we help our customers starting from the compliance till the leading tech part of it, where we cover the emerging trends of today's technologies, covering up with the AI, hardware security, as well as the quantum security part of it. So with this, thank you very much.
So if there are if you have any questions, there is the Q&A box, and you can just type the questions out here, and we'll answer the same. So Anjan, Himanshu wanted to know if there is any prior knowledge, education, or certification which is required, or any work experience required for this certification, and what will be the cost, and is there any renewal cost for the same, like NCP credit?
The CSPA is a program which comes with 3 years of certification period as per as the ANAB is considered, and it doesn't require any prerequisite knowledge for the CSPI. as we walk through from the basic element till the advanced of what is happening with respect to it. And I hope that answers your question, Himanshu.
Any other questions, you can just type it in the Q&A box, and we'll answer the same. So Anjan Anshuman have asked that want to know about the GitHub Copilot, its usability and helpful for software development, and how it will be helpful for a code review.
I think the GitHub Copilot is one section, one primitive use of the Copilot which is happening in this code development. But there are advanced models which are basically available, which are far, far better than the Copilot today, with the Cloud Opus and other models coming up with it. And where the code review part of it can also be much better in terms of what we look at in the especially used for the code development and the code review part of it. This is one section where we see a less amount of hallucination coming with respect to the code, because there is a directed response coming up with the models.
Sure. The next question is that in case if there is any, what are any guardrails that we recommend for any adoption of AI and ML in application?
This is something which is specific to the particular application, and LLM as such, with the raw or the base LLM that we are talking about, doesn't come with a guardrail. It is, domain and a custom oriented specification that requires that is something which is required for the guardrail to be with it.
And there are a lot of questions regarding the fees for the exam, for the training and the exam part.
So probably we'll have to take it
later. Fine.
Yeah.
So another good question is that there are a lot of SaaS products and plugins which boosts productivity. Like for example, the Zoom AI, which are able to capture the meeting notes and help you with the transcripts part. So as it is being will be stored outside India, the question is that can an Indian payment companies use them? Well, I'll try to answer that particular question. The answer is that definitely it all depends on the organization policies and procedures aspect. But if you're using say similar applications and using it for your in your call center contact centers aspect, and at a point of time this confidential information comes into picture, then it's better not to use those applications. But end of the day, it is the policy which is being governed by the infosec team within the organization, or the AI policy which has been implemented by the organizations to determine how to take these solutions and plugins and use the same. The last question, one of the okay, it's already over time. So one last question to you, Anjan, is that how do you compare CSP AI with ISO 42001 lead auditor certification course?
CSPA is not a audited program. It basically covers multiple different governance model and sets the base ready for understanding about the AI in an organization level of what is required to be prepared at a very base level till the point where there is a auditor coming into picture with respect to it. So that is what is the preparation level, what CSPA does with the background understanding of how to handle the security controls with respect to AI, because AI is something which is new to the system, right? So it's not something to do with the auditor program.
Sure. So we do have a few more questions coming in. So participants, if you like to answer, we'll be answering those questions till around 4:10. So if you have any questions, you can type it in. But for those who can want to leave, we'd like to thank you for attending this webinar. And uh, it was nice having a interactive session. We'll continue answering the questions because there are a few more questions coming in, and we would not like to leave anything out. So if you're there, please free to keep on answering, raising these questions, and we'll keep on answering it.
I think there is one last question which we can basically pick up, and this is talking about what are the current best practices to mitigate hallucinations in LLM.
Yeah, sure. So I think the best practice is definitely as LLMs are trained, there'll be a lot of hallucinations happening. And if you, I've been using LLM for the past so many, till from the day one GPT came to picture, I've been using. And I can say with confidence now is that even GPT have started hallucinating in the past 1 month. Uh, and most of it, what is perpetuity or your cloud days, uh, it is hallucinating. So from a system perspective, how it can eliminate is that how much context we can provide, right? So for example, if you're able to bring in say an NCP or a RAG into picture, and if you're trying to limit the LLMs answering to that particular data set, then for that specific data set, you can bring down the hallucination to quite a lot, and the accuracy can increase to almost 99.99%, still not 100% aspect. So that's how we can. So the more context that you provide in your prompt to the LLMs, your accuracy rate increases drastically. So whether it's through a RAG or through NCP, with connecting your database, you can do that. The next one is how can adversarial machine learning are exploited to bypass AI-driven cybersecurity systems, and what strategies can be employed to defend against such attacks? That's a good question. I think last week only we had a new LLM which has been introduced. I forgot its name, which has been in the dark web. So we had fraud GPT and we had worm GPTs, which was basically your Llama LLM models, and they just remove those guardrails to give you those malicious outputs, right? While last week there's a new LLM which has been introduced. I'm not able to recollect its name, which has been trained from grounds up to ensure that it is the intruders can able to build it for phishing, can intruders can be build it for creating malwares which can evade your ADRs and everything. So right now, the only solution that you have is to ensure that the solutions that you use for protecting your systems have AI component in picture, which can able to identify those anomalies and take those decisions. Because it's always intruders are, I'll say that's a little head because I do a lot of forensic investigations earlier, and I know that the way the intruders think is always on an innovation front. So if your AI system, your SIP protection system, whether it's an EDRs, your monitoring solutions, doesn't have that AI capability, then it's going to be very tough to protect against these new type of attacks. Uh, One last question we can take is, yeah, I think Adil, like same question has been answered. But so the next question by Adil is, how can you ensure that AI systems used for cybersecurity and not themselves vulnerable to adversarial attacks or data poisoning? So that's the reason why we mentioned those set of steps, right? You need to ask whether they have taken those necessary steps to ensure that those AI systems are secure, responsible, and trustworthy. Data poisoning, we can able to identify by those data scanning, right? So there is two components. One within the LLM itself, and so here we can do a lot of LLM scanning, LLM red teaming activities to identify whether the LLM is secure enough. The second one is the data set which you feed into your uh, ML and LLM systems. So for those data sets, you definitely needs to do data scanning to identify that data set is poisoned. So whether it is a uh, identifying for confidential data or for identifying for data poison using regex functions or using various ML algorithms to identify whether the data set falls within the data set that is required. So there's a lot of data protection steps which is there, which can be taken to ensure that the data that you feed to a LLM are in the poisoned in nature. But if it's a third party you want to ask, then uh, as part of our CSPA workshop, we do have in the last section, we cover a lot of those questions, which you can ask the third parties to ensure that whatever they developed is a secure, responsible, and a trustworthy AI. Sure. So with that, I think it's already 10 minutes over the timeline. So thank you for attending the session. So we do have our next batch of CSPI next week, starting on June 18th. So if you're interested, you can drop a mail to us and you can get registered there. If not, every month we do have these workshops that we do for CSPI, and we can join the same. Because in next 1 year, most systems will be AI systems, and most regulators and governing bodies are going to ask that how have you ensured that your AI systems is secure, responsible, and trustworthy. With that, thank you, and have a great day ahead.
Thank you. Thank you.